here we are using this property. By using that we are simplifying this integration. So here it is, in place of n what we are choosing, so n is equal to alpha plus 1. So this is one thing. And next, if you compare this one, in place of m what we have, in place of m here it is having 1 by beta. So that one we have to substitute here. Okay. Now if you see that, so in gamma n by, so gamma n is nothing but what we are choosing, alpha plus 1. So alpha plus 1 by, and here it is m power n. So m is nothing but what we said, 1 by beta whole power n. So n is nothing but what we said, here it is alpha plus 1. So that is nothing but 1 by beta alpha power 1 by beta whole power alpha plus 1. And already we said that one, so property we can apply. Before that we can simplify this one. So here it is already what we have here, 1 by beta power alpha gamma alpha. So 1 by beta power alpha gamma alpha, and next, so gamma alpha plus 1. So this is gamma alpha plus 1 by 1 by beta whole power alpha plus 1, right? So 1 by beta whole power alpha plus 1. So this is the one. So now here it is, simply we can write 1 by beta alpha for alpha plus 1. This one goes to numerator. Simply what we can write, that one, gamma alpha plus 1 and beta alpha power alpha plus 1. So that one we can write. So beta power alpha plus 1. And now, so this is simply what we can write, gamma alpha plus 1. And if you observe that, that is in the form of a power m plus n. So a power m plus n, how can I write that one? A power m into a power n. So that is nothing but simply we can write beta power alpha and beta power 1. So already here it is what we have, beta power alpha and beta power alpha both will cancel. And what we said in gamma function property, gamma n plus 1 is equal. So gamma n plus 1 is equal, simply how we are writing that, n into gamma n. So this is the property we are using, gamma n plus 1 is equal n into gamma n. So by using that, in place of gamma alpha plus 1, what we can write, in place of n what we have, alpha. So for that, alpha into gamma alpha into beta. So alpha into gamma alpha into beta. So this one we are writing. And is there any cancellation one? So here already what we have, 1 by gamma alpha. After cancellation of beta power alpha, what about remaining? 1 by gamma alpha into alpha gamma alpha beta. So here it is gamma alpha both will cancel. And remaining what we have, alpha beta. So this one what we calculated, mean. So mean mu is equal to alpha beta. So this is the one. Okay. Here what we applied for calculating mean, we used continuous distribution formula, expectation. E of x is equal to integral minus infinity to infinity x into f of x dx. But as per the probability density function, we are splitting the function f of x into two subintervals. One is when x is greater than 0, 1 probability density function, and rest of the cases we put it as 0. So for that, integral minus infinity to infinity, we split it into two subintervals. Okay. In first subinterval, minus infinity to 0 we chosen, and x into f of x. So for that, there it is, we wrote it as x into 0 dx. So this is one. And next another one is 0 to infinity x into f of x dx. Here it is x greater than 0 is nothing but what we are saying, 0 to infinity. So x into f of x is nothing but what we are using, that formula we wrote. So x into beta power alpha gamma alpha x power alpha minus 1 into e power minus x by beta. So this one we wrote, right? So e power minus x by beta. So this is the one we wrote, and we simplify. So for simplification we used a power m plus n is equal a power m into a power n. Another one is, this is the one. And next another property we use, gamma n plus 1 is equal n into gamma n. So all these things we used for proving mean of a gamma distribution is alpha beta. Next we are going to prove that variance. So for proving variance we require mean also, right? So this is all total what we wrote there. So finally we got it, mu is equal alpha beta. Next, for a continuous probability distribution, we are finding variance. Okay, so variance we are writing. So variance formula we already know that. What about that? Variance of x is equal. So v of x, or simply we can write sigma square also. Sigma square is equal to e of x square. Generally, what we got? E of x square minus e of x whole square. So this is the formula we use for calculating variance, right? So e of x square minus e of x whole square. So this is the formula we are using for calculating variance. So e of x square minus e of x whole square. So e of x square is nothing but what we are using in continuous distributions. So integral minus infinity to infinity, e of x square is nothing but simply what we are writing, x square into f of x dx. So x square f of x dx, and e of x is nothing but simply what we are saying, mean. So mean mu. So that is simply minus mu square. So why? Because expectation is equal mean. So in place of e of x simply we wrote mu. And next here also same like as previous one, we are splitting into two subintervals. Why? Because there it is the density function, we have two subintervals. One is minus infinity to 0, x square f of x dx. So x square f of x dx, and another subinterval plus 0 to infinity x square f of x dx. So this is another subinterval. So what about another one? Integral 0 to infinity x square f of x dx. So this is another subinterval. So what, as for the definition of gamma distribution, we are choosing the function, the density function f of x. In this subintervals, the density function is 0. So for that, we put in place of f of x as 0. If f of x is 0, obviously 0 and anything is 0. The entire term becomes 0. Now we are going to take only this one. Of course, minus mu square as it is. Well, already we calculated mean. Simply we can substitute that one in place of mu. So here it is, f of x is nothing but what we are using in gamma distribution, 1 by beta power alpha, gamma alpha x power alpha minus 1 e power minus x by beta dx. So this is the formula we are using. So from this one to this one, how we got it? So we split it into two subintervals. After splitting into subintervals, in first subinterval the value is, the function value is 0, and second subinterval x greater than 0. So here we are choosing in place of f of x as this one, and here it is, we are going to simplify that. Okay, so here for separately we calculated first e of x square and then we simplified that, or directly you can take as it is and then we can simplify also. Okay, now we are going to simplify that. Here it is. So first x square, there it is having what we have. In place of this, first the previous step is integral 0 to infinity x square into, so x square into x power alpha minus 1. There it is. In previous step we have x square x power alpha minus 1, right? So here it is, with this is, if you observe this one in the form of a power m into a power n. So that is simply what we can write, a power m plus n. So a power m plus n, that only we wrote here. So x power 2 plus alpha minus 1. Same like as previous one, we are writing as x power alpha plus 2, putting in one bracket minus 1 e power minus x by beta dx. So here also same like as previous one, what we used, that formula here we are using. What about we used? E power, sorry, x power n minus 1. So n minus 1 e power minus mx. So e power minus mx dx is equal. So dx is equal, which formula we applied there? Gamma n. So gamma n by m power n. So this is the formula we used, right? So gamma n by m power n. Same this one we are going to apply here. See here, if you compare this one, in place of n what we have, alpha plus 2, and in place of m here it is, we can write as 1 by beta. So 1 by beta. So m is equal to 1 by beta and n is equal to alpha plus 2. And simply we can write in place of n as alpha plus 2. So for that gamma of alpha plus 2, and in place of m what we chosen 1 by beta. So for that 1 by beta whole power alpha plus 2. Now we are going to simplify this one. Okay. Now here for simplifying, so what we have here it is 1 by beta power alpha gamma 2. So gamma alpha, sorry, not 2, gamma alpha into gamma alpha plus 2. So gamma alpha plus 2 by what we have, so 1 by beta whole power alpha plus 2. So when it comes to, when you take that one into numerator, if 1 by beta whole power alpha plus 2 is nothing but, simply we can add beta power alpha plus 2, right? So beta power alpha plus 2. And as it is this one, we are not changing anything this. So we are writing as this 1 by beta power alpha gamma alpha. So this is as it is we are writing. And next, here it is gamma alpha plus 2. How can I write this gamma alpha plus 2? Can you write this one as alpha plus 1 plus 1? So alpha plus 1 plus 1 and into, and beta power alpha plus 2. This is in the form of a power m into a power m plus n. Simply we can write that is a power m into a power n. So that is nothing but beta power alpha into beta square. So a power m into a power n, a power m plus n. So if you cancel these two, beta power alpha both will cancel. So what about remaining here it is gamma alpha plus 1 plus 1. So alpha plus 2 we are writing as gamma alpha plus 1 plus 1 by gamma alpha into beta square, gamma alpha into beta square. So this is the remaining one. Okay. And now we can simplify this one. Can you write this one as same gamma function property? So gamma alpha plus 1 or gamma n plus 1 is equal to what we are writing, n into gamma n. So that is simply what we can write here it is alpha into gamma alpha, right? So gamma alpha plus 1 is nothing but we can write like this. Here it is, if you observe this one, in place of alpha plus 1, you can take it as n. So gamma n plus 1 is nothing but what we are writing, n into gamma n. It means simply what we can write, alpha plus 1 into gamma alpha plus 1. Alpha plus 1 into gamma alpha plus 1 by alpha plus 1. Sorry, gamma alpha as this. We are not changing anything. Beta square. And now, so alpha plus 1 as this, we are not changing anything, we are writing as this. And in place of gamma alpha plus 1, so what we can write again by using gamma function property, we can write alpha into gamma alpha. So the total one we are writing as alpha plus 1 as this, gamma alpha plus 1 we wrote alpha into gamma alpha. Here it is gamma alpha both will cancel. And what about remaining there? So remaining here it is only one thing. What about that? Alpha plus 1 into alpha into beta square, right? So this is the one remaining. This is only we calculated u of x square. Okay, minus mu square we have. Minus mu square is nothing but, mu is nothing but mean what we got it, alpha beta, right? Alpha beta whole square. So this is mean we got it. Now we are going to simplify this. For that you can multiply the terms. Alpha into alpha is nothing but alpha square. So alpha square beta square plus 1 into alpha beta square is nothing but alpha beta square. Next, minus alpha beta whole square there. So ab whole power m, a power m, b power m. So that is nothing but simply what we can write, alpha square beta square. So here it is, this one and this one cancel. And what we got it finally, alpha beta square. So this is the variance of gamma distribution. Okay. So what we did, the